before I talk about simplifying rational expressions, I just want to give you a word of encouragement. Your success is not necessarily based on how much you know, but on the attitude and approach you have towards what you do not know at the moment in math, biology, and so on. This is, of course, applying to our math class. And the other question I want you to think about is, what do I want? What is the point of all this? Why do I go to school? What's the reason? I want you to ask yourself those questions, because that would help you in getting motivated. Vision and purpose are great things, or things that could help motivate us in doing what God calls us to do. So I want to encourage you to remember that. And remember again, when I was thinking of this quote yesterday, one of the things I was trying to get at is, sometimes you don't understand the topic in question, but you just need to talk to the teacher, look for someone, do some examples, do some extra problems, and you begin to understand how to handle them. So remember, your success is not based only on what you know, but how you react to the things you don't know. Here are a few examples of rational expressions. The first one, we have minus 2q cubed over 16q. We simplify the 2 over 16. It becomes 1 over 8. And then for the q, we bring this q here. We use one of the laws of indices, which says since we have the same base, we can bring that up, and so we get cube 3 minus 1. So it becomes q squared over 8. The excluded value is 0. You can't have 0 in the denominator. The second example, s plus 1 divided by that. When we simplify that, we get s plus 1 over 15 into s plus 1 times s plus 1. The excluded value is 1, of course, well, minus 1. Because if you put a minus 1, you get 0, and that makes everything 0. And then we move on to the simplified form. The s plus 1's cancel, so we get 1 over 15s plus 1. We can distribute this, and we get 1 over 15s plus 15. The third example is simply dealing with the x's, x squared over x. We could just bring the minus 1 up there. Remember again, whenever you have xm over xn, you can write it as xm minus n. That's all I'm doing. Now, what if it was xm over x minus n? That becomes xm minus n, which is xm plus n. We'll come back to that in a second. 4x to the fifth power over 12x. The 4 over 12 can be simplified to 1 over 3. X to the fifth power minus 1. We get x to the fourth power, and then the 3 is on the bottom. So x to the fourth power over 3. Excluded value was 0, because when you have a 0 here, it will make this whole thing, it will be undefined at that point. Number 5. When you have an expression like that, one of the first things you want to do is put the like variables together. So put all the b's together. So we bring them, and we then simplify using the law that tells us xm times xn is the same thing as xm plus n. That's how that works. So remember, we just add the exponents because they're all on the same line. And that's what we get as our final answer. Number 6 is similar, but you have something over something. So all you need to do is deal with the top, deal with the bottom, and then go ahead and add them together. So you can look at that for a second and see how that's done. Again, you bring the b's together. We have b to the first power minus 2, because a minus times a plus is minus. A minus times a minus is minus, and a minus times a minus is plus, and a plus times a plus is plus. So remember that. Minus times plus is minus, plus times plus is plus, minus times minus is plus. And so because we have a plus, a 1